I'm going to start out with a subject matter that came up this week. Saw an article and they talk about the origin of life on Earth. Let's see what that is about. And it says the following. It says, life on Earth had to begin somewhere, and scientists think that somewhere is Luca, which is the last universal common ancestor. Okay? And it says this Luca fella showed up 600 million years after the planet's formation, which was 4.6 billion years ago. And the question is whether that's true, whether the planet formation, whether the planet formed 4 or 5 billion years ago. That's the issue that I'm interested in looking at. Not so much the life, because I think a lot of that is, there's more speculation there. But the question is whether the planet, started out 5 billion years ago. That's the issue, okay? And where did they get this number? They got it from here. Here you can see the Wikipedia, the peer-reviewed encyclopedia, right? The Hadean is the first and oldest of the 4 known geologic eons. And it says, starting with the planet's formation about 4.6 billion years ago, okay? How do they determine that? And they say it's the oldest solid material in the solar system found in some meteorites. Okay, so that's the best estimate they have today, because they found some of this stuff in meteorites and they dated it somehow to about 4.6 billion years ago. Okay, and then they looked at some rocks here on Earth as well. Okay, but that's the main one. They say, look, the oldest rocks we found in the solar system are 4.6 billion years ago, so that's the best estimate we can give for the start of the Earth. Where did they get these things? I mean, the fact that, let's even concede, let's assume that the oldest rock that they found is 4.6 billion years ago, meaning a meteorite, could be an asteroid or a piece of a comet, who knows what. It doesn't really matter. If you find that, what does that have to do with the start of the Earth? And this is the theory. The theory here, I'll illustrate it for you, has to do with this. And it's what is known as the Nebular Hypothesis. They say there was a gas floating around in this region of the universe. At some point, the star, our sun, turned on, and all the other planets were made from this same gas. Okay, so that's essentially the story. That's the official version. And so this, all the planets came out a little after the sun turned on, or around the same time. If the sun is 5 point something billion years old, then the planets came out a little later, okay? And they formed from the same gas. That's the issue. And here you see another version of that. Again, I want to illustrate this so that people get the hang of what's out there, okay? You can see the gases floating around, okay? And suddenly they start spiraling, right? And from that gas nebula, all these gases, the planets came out, okay? They formed according to the official version. There you see the little planets being formed from these little spirals, and from this one the Earth forms, okay? So makes sense, okay? And the question is whether this is true at all. And the main thing I want to question is whether the Earth can form from such a small ball of gas, okay, spiraling gas or whatever. And even if you throw in there, rocks, metals that were, debris that was in our neighborhood, even if you throw that in there, the question is whether, you can make the Earth, there you see the Earth spinning, whether you can make this Earth from such a tiny amount of gas, okay? That's the issue. And so we question that. We question whether that could happen at all. Now, we're not questioning that the sun came from a nebula. That's not the issue. I concede that one. What I don't concede is that the planets came out of the same nebula as the sun. Okay, I want to put that in the right place. Why do I have a problem with the nebular hypothesis as applied to planets? Okay, in other words, being from the same gas material that made the sun. That's the issue, right? Why do I have a problem with that? Well, here it is. The Earth has all these different layers. Okay, it's what is known as differentiated. Okay, so it's got a crust, upper mantle, outer core, inner core, etc. It's got all these levels. As you get deeper into the center of the Earth, you find the metals, or you could say the heavier metals or heavier elements. And as you get to the upper part of the Earth, you're going to find, silicon and lighter elements. And finally, at the very top, you find what? Water and gases, which are the lightest of all elements. So you go from very heavy elements in the center to lighter elements on the outside. And not only our Earth is like that, as here you have these other planets, Mercury, Venus, and Mars, the other rocky planets. And I didn't mention Pluto. Okay, some say it's not a planet. Okay, so the question here is, all these planets, these celestial objects, they're all differentiated. And above all, they're round. You could say they're perfectly round. From afar, they look perfectly round and smooth. I'm sure if you get close next to them, you'll find some bumps and, mountains and valleys, etc. But from afar, it's essentially they're spheres, smooth spheres, all of them, including the Earth. Okay, and so the question is, how do you produce that? How do you produce differentiation, and how do you produce roundness? And I'm saying all those were stars. That's what they were. I didn't come up with this theory. Unfortunately, I didn't learn it either in high school or in college. I found out in a roundabout way about it very late in life, essentially, while I was running this channel. And the question is, why isn't this taught in high school? I mean, you can go along with a nebular hypothesis, no problem, but you should present other theories as well. And this theory is never presented, and this theory has been around since, I think, 1926, okay, which is Alexander Oparin, Russian guy. That's the earliest I hear of who came up with this. There could have been someone even before then, but he's the first guy that I read it from. And so why isn't this taught in schools? And yes, I doubt very much that from a small amount of gas, here it is again, for your visualization, whether this could really be possible, for the planet, especially the Earth, to come out of a small amount of gas and be so round and differentiated. And my answer is no. The only way you can produce this through extreme gravitational processes like what occurs in stars, and that is the reason it's differentiated and it's round. And that's same for any object that is round in the solar system. Now, what would that mean? Well, it means that by definition, according to the definitions they have out there, I'm just going to use the ones that are out there, the Earth is what is known as a black dwarf. Okay, what is a black dwarf? A star that no longer shines. Just compressed, became round, differentiated, like all stars, right? And then it's just some debris that's floating around there waiting to be found. And if you say, well, the same happened to Mars, the same thing happened to Pluto, the same thing happened to all the asteroids, Venus, Mercury, right? All the moons rolling around Jupiter and Saturn and Uranus and so on. Well, when you look at that, you say, well, all these roundish objects out there, celestial objects, they weren't formed from the gas cloud that made the sun. They were already there before the sun turned on, ignited. Okay, they were already there. They're captured objects. And one of the arguments that I have also against the nebular hypothesis is that you have planets like Jupiter and Saturn. They're gaseous planets, these balls of gas. They are essentially stars that never ignited, and they're at a certain radius from the sun. Okay, they're rolling around the sun at a certain radius. And they have these little moons, rocky moons, rolling around essentially in the same radius, right? A little farther out, a little closer sometimes, because they go around Jupiter, for example, as it rolls around. You have Ganymede, Europa, Io, you know. And so they go around the planet, Jupiter goes around the sun, and these little rocky moons are at the same, more or less, the same radius from the sun. How can you get a gaseous ball like Jupiter and next to it at the same radius, these rocky moons? Why didn't they end up being gaseous as well? And so, you know, they don't have an answer for these. They don't even ask these questions. They never ask these questions, I guess. You know, and so, yeah, I have a big problem with all the planets being part of the same gas system that made the sun. The argument is that the sun was the last member of the solar system. When it ignited, all the planets were already there. All the celestial objects were already there. Some of them billions, trillions years old. Yes, you heard right. Trillion, maybe quadrillions years old. You say they can't be because Big Bang only goes, 13.7 billion years ago. And that is essentially the argument that these people raise. You know, it says a black dwarf is a theoretical stellar remnant, right? And what is the problem with it? Well, because the time required for a white dwarf to reach this state is calculated to be longer than the current age of the universe, 13.8 billion years, no black dwarfs are expected to exist in the universe at the present time. That's the whole thing. That's the whole problem. Okay? So yeah, if the Earth is a black dwarf, it destroys Big Bang Theory because the Earth is much, much older, trillions of times older than the sun. It was a star at some point in time, cooled down, lost all the so-called energy, light, doesn't shine anymore. You know, it's not a star anymore, but it's already differentiated and roundish. And it was sitting there when the star known as the sun turned on, ignited, and because the gases were swirling, all these planets ended up rolling around the sun.